Having brought the ore in that form which can be easily reduced, that is the oxide form, there are a number of reducing agents which convert the oxide to metal. This step of metallurgy is called smelting. Smelting is a process of reduction of the oxide ore into metal by using a suitable reducing agent. Carbon is very often used as the reducing agent for various reasons. Carbon is easily available and the process is economical. Many of the metal oxide ores are reduced by carbon. For example, zinc oxide, when heated with carbon in the form of coke is used as a reducing agent. Zinc and carbon monoxide are formed. Carbon monoxide itself can function as a reducing agent. The carbon monoxide form will further reduce zinc oxide to zinc. Lead oxide can be reduced by heating lead oxide with coke to lead and carbon monoxide is formed. Carbon monoxide also reduces lead oxide to lead. Ferric oxide can be reduced by coke to iron. Carbon monoxide is the byproduct. Carbon monoxide also reduces ferric oxide. To iron and forming carbon dioxide. So these are some of the examples where coke is used as a reducing agent. Coke is converted into carbon monoxide. Carbon monoxide also reduces metal oxide to metal. In this smelting process, some additional substances are also added to remove the impurities present in the concentrated ore. If the impurity is acidic, then the additional substance added must be a base. This additional added substance is called a flux. So, flux is added to the ore to remove impurities. If the impurity is acidic in the form of silica, then the flux must be a base. For example, calcium oxide is a basic flux. Which is added to remove silica. Calcium silicate, easily fusible mass called slag, is formed. If the ore contains basic impurities, then the flux must be acidic. For example, if the ore contains ferrous oxide as impurity, then silica is added. The function of silica is now a flux. Silica is functioning as acidic flux which has been added to remove the basic impurities in the form of ferrous oxide. Ferrous silicate, an easily fusible mass called slag is formed. The slag is in the molten form, it is lighter, it floats on the surface of molten metal that further prevents the oxidation of metal. Some of the metal oxides, when reduced with coke, require very high temperature. The process becomes uneconomical. Not only that, at high temperature there is a possibility of metal combining with carbon to form carbides. Therefore, in some of the metal oxides, highly electropositive metals are used as reducing agent, particularly aluminium. The oxidation of aluminium to alumina is highly exothermic reaction. So heat produced during the oxidation of aluminium to aluminum oxide is utilized for reduction of some of the metal oxides. Electropositive metals are used as reducing agent. For example, aluminium is used for reduction of manganese oxide. Mn3O4, when heated in presence of aluminium, aluminium is oxidized to aluminum oxide. The whole process is called aluminothermic process. The oxide ore is mixed with aluminium and heated. Aluminium gets oxidized to aluminum oxide and metal oxide is reduced to metal. Manganese dioxide is also reduced by aluminium to manganese. Chromium oxide is also reduced by aluminium to chromium. Boron oxide. Boron is a non-metal. Boron oxide B2O3 is also reduced by aluminium to boron. Other electropositive metals like magnesium, like sodium, potassium, they are also used for carrying out the reduction process. For example, B2O3 can be reduced by magnesium. Magnesium is also used for reduction of silica to silicon. not only oxides, the halides of titanium are also reduced by electropositive metals. It's rather difficult to reduce the oxide of titanium. So titanium halides are reduced by magnesium or by sodium. When titanium tetrachloride is heated in presence of magnesium, this process is known as Kroll process. Titanium tetrachloride can also be reduced by sodium. So these are some of the examples where electropositive metals are used as a reducing agent. In addition to electropositive metals, in some cases hydrogen is also used as a reducing agent. But there are limitations because hydrogen being highly inflammable, so hydrogen is used in limited cases. Hydrogen as a reducing agent. For example, cobalt oxide is reduced by hydrogen to cobalt. Magnetite Fe3O4 can also be reduced by hydrogen. Some of the complexes like ammonium tungstate is reduced by hydrogen. Similarly, ammonium chromate So these are some of the reduction reactions of hydrogen. In these reactions, hydrogen has been used as a reducing agent. Now we have seen number of reducing agents like coke, carbon monoxide, electropositive metals, hydrogen. How do we decide that which metal oxide is to be reduced by which reducing agent? Or economically, which reducing agent will be better? The reduction process is decided by thermodynamic means.